good day to my fellow teammates. I hope you guys are doing good at home. Today we want to do a discussion about the basic pneumatics by using a software called Festo Fluid Sim that we watched a couple of days ago. I wanted to ask you guys of what you have all learned from that video. Maybe we can start on basic pneumatic first.
Sure, Rafiq. May I start? So, I will explain about basic pneumatics. In industrial automation, basic pneumatics involves utilizing compressed air to control and power machinery for various tasks. This branch of engineering focuses on principles such as pressure transmission and gas behavior to create motion or force. Common components include compressors, valves, cylinders, and actuators. Industrial automation applications include pneumatic drills, cylinders in machinery, brakes in vehicles, and systems for automation and robotics.
Thank you, Faik. It was insightful. I appreciate how you explained about basic pneumatics. It helped me understand the fundamentals better. From the video, I saw he used the single action actuator and double action actuator. Where from what I know, single action actuator, which also known as single acting cylinder, this type of actuator uses compressed air to move the piston in one direction only. The return stroke is achieved by a mechanical spring or by the force gravity. Single actions actuators are often simpler and more economical than double action actuators, but they are limited to application where movement is only one direction is required, such as in opening or closing a valve. Meanwhile, double action actuator, which also referred to as a double acting cylinder, this type of actuator uses compressed air to move the piston in both directions. Compressed air is supplied alternately to each side of the piston, causing it to move back and forth. Double action actuators are commonly used in application where precise control of movement in both directions is needed, such as in linear motion system, clamping device, and robotic arms.
Mm, I see. And seeing the animations in the software help visualize how the airflow affects the movement of the piston in both types of cylinders. As I remembered, in the video, he used a directional control valve that acts as a switch to extend and retract the cylinder of the actuator. Is it right, Afiq?
Yes, of course, I remember it too. Would you mind to explain to that to us, Faik?
Sure, sure. Right. So we have in our simulation we use two directional control valve, also known as DCV. Uh, the first DCV we use is 3/2 way. Right. So this type of valve has three ports and two positions. The three ports are typically labeled as pressure inlet, output or working port, and exhaust. Okay, so as you can see here, 1, 2, 3. In a 3/2 way valve, the valve can be in one of two positions, either connecting the pressure inlet to the output port or connecting the output port to the exhaust port. These valves are commonly used in applications where a single acting actuator needs to be controlled, such as in cylinder operation, where extension and retraction are needed. So as you can see here, we can control the inlet and the outlet of the airflow. So for the 5/2 way DCV, this type of valve has five ports and two positions. The five ports are typically labeled as pressure inlet, output or working port, another output port, and two exhaust ports, often labeled as R1 and R2. In a 5/2 way valve, the valve can be in one of two positions, either connecting the pressure inlet to one of the output ports, whilst simultaneously connecting the other output port to one of the exhaust ports. Right. So these valves are commonly used in applications where a double acting actuator needs to be controlled, such as in linear motion systems or robotic actuators, where precise control of both extension and retraction is required. So for the 5/2 way directional control valve, this is the simulation.
Thank you, Faik, for the explanation. If I'm not mistaken, there is another component in the system called a throttle valve, which also known as a flow control valve or speed control valve. Is a component used in pneumatic system to regulate the flow of compressed air to control the speed of motion in pneumatic actuators, such as cylinders, specifically in the context of controlling the speed of retraction and extension of a cylinder. A throttle valve is used to adjust the rate of at which air enters or exits the cylinder. Faiz, would you mind explaining to us about how it works?
Yeah, sure. Here, how a throttle valve works in controlling the speed of cylinder motion. The first one, controlling airflow. A throttle valve is installed in the pneumatic line that supplies air to the cylinder. By adjusting the position of the throttle valve, the flow rate of air entering or exiting the cylinder can be controlled. The second one, speed regulation. By restricting the flow of air through the throttle valve, the speed of the cylinder's motion, both extension and retraction, can be regulated. When the valve is practically closed, the flow of air is reduced, resulting in slower movement of the cylinder. Conversely, opening the valve allows more air to flow, increasing the speed of cylinder motion. A third one, precision control. Throttle valve allow for precise control over the speed of cylinder motion. This is crucial in the applications where precise positioning or controlled acceleration or deceleration of the cylinder is required. The The next one, adjustability. Throttle valve are typically adjustable, allowing operator to fine-tune the speed of cylinder motion according to the specific requirements of the application. This adjustability enables flexibility in controlling various loads and operating condition. And the last one, pressure compensation. Some throttle valves are equipped with features for pressure compensation, ensuring consistent speed control regardless of fluctuation in system pressure.
Faik, your mic. Faik, mic.
Baik.
Faik, mic.
Oh, thank you, Pak for the explanation and sorry for the mic. Right. So if my memory serves me right, pneumatic system compressed air line can be few hundred meters long. So it will have a built-up pressure in the line that will slowing the actuator to extend and retract. Alright, so I will show you guys. Okay, so we countermeasure or solve it by using quick exhaust valve to directly release the compressed air from the cylinder. Okay, so this is the um, quick exhaust valve, right? So a quick exhaust valve will let the air out directly here at the cylinder. You see the exhaust here, port 3, and we don't have to go all the way back. So now the extension is run at the maximum speed, right? Air can flow on the right, and if we are retracting, air can still flow to the line. Yeah, as you
I
can see
see.
here, air still can flow through the line. Yeah, right. If we are
Yeah.
retracting, yeah, right. Thank you.
Mm. From what I can conclude from this discussion, single and double acting cylinders, flow control valves, directional control valves, compressed air, supply source, and quick exhaust valve are all integral components in pneumatic systems. Each plays a crucial role in controlling the movement and direction of pneumatic actuators, ensuring efficient operation and precise control in various industrial applications. Single acting cylinders operate with air pressure in one direction, while double-acting cylinders use air pressure in both directions, offering more control over movement. Flow control valve regulate the speed of cylinder movement, enhancing precision and safety in pneumatic system. Directional control valves manage the direction of airflow, enabling the desired motion of actuators. A reliable compressed air supply source is fundamental to the functioning of pneumatic system, providing the necessary pressure for operation. Quick exhaust valve facilitate rapid release of compressed air, minimizing cycle times and improving overall system efficiency. In conclusion, the proper selection of integration of these components are essential for the optimal performance of pneumatic system, ensuring smooth operation, precision, and safety in various industrial settings. All right, that's all from us. So
Wait, wait,
thank you
wait,
for
wait.
yes.
Before that, I also want to show something related with speed. So this is our last
Oh,
discussion.
sure,
Okay.
sure.
Okay.
So okay. So as we can see here, we can also adjust the opening level to get the
More
suitable
smooth.
amount of value for our speed. Let's say
Oh.
if I change if I make it max, uh, you see the airflow through the line is very fast. So it will resulting in the piston to what you say to broke fast. We don't want that. So we adjust the opening level. Let's say I want to make it 10,
Oh, make it slower, move
make it
slower.
slower.
Oh.
We cannot
Oh,
see we cannot see uh easily on the software, but that is the theoretic. That is the theory. No,
I see.
same goes with
Understood.
this one. Same goes with
Double action.
double action. Yes.
Oh. New level.
So, you see, it becomes slower
Slower, yes.
than before, right? Right. So
Yes.
that's all I want to show. Thank you.
Oh, I
Thank you,
see.
Faik.
Okay. Okay, thank you for it.
All right, that's all from us. Sure. Anything more?
Nothing.
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 All
Right.
right.
Thank you.
That's all right. Thank you. That's all from us. Thank you and assalamualaikum.
Salam.